the universe has always captivated the human imagination. From the earliest days of civilization, we've looked up at the stars and wondered, how did all of this come to be? What is the true nature of the cosmos, and how did it evolve to become the vast expanse we see today? Over the centuries, through scientific inquiry, we've developed models and theories that aim to explain the origins and evolution of the universe. One of the most prominent of these is the Big Bang theory, which suggests that the universe began as an incredibly hot, dense point roughly 13.8 billion years ago and has been expanding ever since. For decades, this theory has been the cornerstone of cosmology, backed by a wealth of observational evidence, including the discovery of cosmic microwave background radiation and the observed redshift of galaxies. But now, thanks to cutting-edge technology and groundbreaking discoveries from the James Webb Space Telescope, we are faced with a new dilemma that threatens to shake the very foundation of our understanding of the universe. New data is revealing that the universe may be far stranger and more complex than we ever imagined, and some of our most established theories might not be able to fully explain what we are seeing. The James Webb Space Telescope, launched on December 25, 2021, was designed to revolutionize our understanding of the cosmos. A marvel of modern engineering, it was specifically built to observe the universe in the infrared spectrum, allowing it to peer into regions of space that were previously obscured by dust or too faint for older telescopes like Hubble to detect. Webb's capabilities go far beyond those of any previous space telescope. Its infrared sensors allow it to capture the faintest glimmers of light from the earliest galaxies, and it has already uncovered the oldest known galaxies in exquisite detail. But while these discoveries are thrilling, they are also posing some of the most perplexing questions that cosmologists have ever faced. With each new revelation, we are forced to confront the possibility that much of what we thought we knew about the formation and evolution of the universe could be wrong. One of the most significant discoveries made by the James Webb Space Telescope in recent years involves 6 ancient galaxies that have completely upended our understanding of the early universe. These galaxies, which existed between 500 and 700 million years after the Big Bang, are far larger and more massive than anyone could have predicted. According to the current cosmological model, the first galaxies should have been small, faint, and relatively simple, with only a few stars scattered throughout. But the galaxies discovered by Webb are anything but small. In fact, their masses are comparable to that of our own Milky Way galaxy, which is made up of more than 100 billion stars. Some of these newly discovered galaxies even have masses greater than 10 billion solar masses, with one of them possibly surpassing 100 billion solar masses. This is a staggering revelation, as it suggests that these galaxies formed much more quickly and on a much larger scale than current models of cosmic evolution would suggest. The discovery of such massive galaxies in the early universe is particularly baffling because, according to conventional cosmology, there simply wouldn't have been enough matter in the universe at that time to form such large structures. After the Big Bang, the universe was filled with hydrogen and helium, the lightest elements, and the process of galaxy formation was thought to take millions of years. But these 6 galaxies, with their enormous masses, appear to have defied this timeline, raising the question, how did they form so quickly and become so massive? This is where things get really interesting, and even more confusing. Initially, scientists thought that they might have made an error in their observations. After all, how could such large, complex galaxies exist so soon after the Big Bang? But after multiple checks and recalculations, the data turned out to be accurate. These galaxies really do exist, and they are much larger and more mature than they should be based on our current understanding of the universe. This discovery has sent shockwaves through the cosmological community. If even one of these galaxies is real, it could have profound implications for our understanding of the early universe. The conventional model of galaxy formation, which assumes that galaxies grow slowly over time from small, faint beginnings, simply cannot explain these massive galaxies. It suggests that either the density of matter in the early universe was much higher than we thought, or that galaxies in the early universe grew in a completely unknown way. Either explanation would completely upend current cosmological models, forcing scientists to rethink how galaxies formed and evolved in the first few 100 million years after the Big Bang. But the story doesn't end there. Just when it seemed like the dust was settling around these 6 massive galaxies, the James Webb Space Telescope struck again with an even more mind-blowing discovery. In 2023, researchers identified the most distant galaxy ever detected, a galaxy that existed just 290 million years after the Big Bang. This discovery, which shatters the previous record by a full 10 million years, has raised even more questions about the early universe. The galaxy, known as JWST 140, is incredibly luminous, with a mass that likely exceeds several hundred million solar masses. Once again, we are faced with the mystery of how such a massive and bright galaxy could have formed in such a short amount of time. Current models of galaxy formation suggest that it should have taken billions of years for a galaxy like this to form, but JWST 140 seems to have done so in less than 300 million years. This raises the possibility that the early universe was much more complex and active than we ever imagined. One of the most perplexing aspects of this discovery is that JWST 140 is not only massive and bright, but it also contains the signature of multiple generations of stars. The galaxy's spectrum shows bright emission lines from both hydrogen and oxygen, which indicates that several very massive stars had already gone through their life cycles and exploded as supernovae long before the galaxy was observed by Webb. This is a striking finding, as it suggests that the processes we associate with star formation and galaxy evolution may have occurred much earlier than previously thought. In fact, it raises the possibility that the early universe was filled with massive stars that lived short, intense lives, exploding in supernovae and enriching the surrounding gas with heavy elements long before the first galaxies began to take shape. This discovery of such an early and highly evolved galaxy once again calls into question everything we thought we knew about the universe's early history. If galaxies like JWST 140 existed just 290 million years after the Big Bang, how many other massive galaxies might still be waiting to be discovered? And how did they form so quickly? These are the kinds of questions that are keeping cosmologists awake at night. The more they look into the data provided by the James Webb Space Telescope, the more they realize that the early universe was far more complex and dynamic than they ever imagined. What does all of this mean for the Big Bang Theory? For decades, the Big Bang Theory has been the dominant explanation for the origin and evolution of the universe. According to this theory, the universe began as a singularity, a point of infinite density and temperature, roughly 13.8 billion years ago. This singularity then exploded, sending matter and energy flying outward in a massive expansion that has continued to this day. The theory has been supported by a range of evidence, from the observed redshift of distant galaxies to the cosmic microwave background radiation, which is thought to be the afterglow of the Big Bang itself. And yet, despite its successes, the Big Bang Theory has always been far from perfect. There are still many unanswered questions, and recent discoveries are making it clear that some of the theory's key assumptions may be flawed. For one thing, the Big Bang Theory suggests that the universe began from an infinitely hot and dense state, but how could something come from nothing? This question has baffled physicists for years. If time itself began with the Big Bang, then what could have caused it to happen? Was there a trigger for the Big Bang, or did it occur spontaneously? Some scientists, including Stephen Hawking, suggested that the Big Bang could have been a natural event that occurred as part of the laws of physics, with no external cause or explanation. But even this raises further questions. How could the universe have come into existence without any external cause? And why does the universe seem to be so finely tuned for life? These are the kinds of questions that have led some researchers to reconsider the validity of the Big Bang Theory. One alternative to the Big Bang Theory that has gained traction in recent years is the idea of a Big Bounce. According to this hypothesis, the universe is not a one-time event but rather part of a cyclical process. In this model, the universe undergoes an infinite series of expansions and contractions, with each cycle beginning with a bounce rather than a bang. This idea suggests that the universe has no true beginning or end but instead follows a perpetual rhythm of birth and rebirth. If this model is correct, then the Big Bang that we observe today might not have been the true beginning of the universe, but rather the latest in a long series of cosmic cycles. While this theory is still speculative and lacks definitive evidence, it offers a compelling alternative to the traditional Big Bang model. Another fascinating idea comes from the field of quantum physics and string theory, which suggests that the universe we see may not be the real universe at all. According to some proponents of this view, our entire cosmos could be a simulation, a projection on a two-dimensional surface, much like a hologram. This theory, known as the holographic principle, posits that the universe we experience is an illusion, with the true nature of reality existing in a higher dimensional space. While this idea may sound outlandish, it has gained some support among theoretical physicists, who argue that it could help explain some of the strange phenomena observed in the quantum world. If the universe is indeed a simulation,